Oh, hello. Mhm. No, you're muted.
Oh, shoot, shoot, shoot. Can you hear me?
Hi.
Hello, hello,
Yeah,
hello. Yeah, yeah. Yeah. How was your day today?
that's pretty chill.
Pretty chill. That's good.
Yeah.
That's good.
First Viz 2B live. I just got out like 10 minutes after
Oh,
because it was just attendance.
oh, right, just attendance for Biz two
Oh, it was
uh
my first lab. Yeah.
first lab. I see, I
So I
see.
didn't, so I don't get dropped from the course.
That's good. Yeah. Where do you study usually? Do you study at home or do you study at the library on campus, like
I,
Saturday?
I study in like, I study in Valemire Hall. You know what that hall?
Environment. Oh, I've heard of that before, but I
Though,
don't think I've had a class there before.
yeah, I just study there
I
because no
see, I
one
see.
goes there.
Oh, like you study by yourself, like with no friends, like study alone.
Oh, sometimes because I've
Uh-huh.
like there's like a room with like a code and I know the code. I shared the code with some
Uh-huh.
people from my OChem class. So we just study
Right, right,
there.
right, right. Yeah, yeah,
Yeah.
yeah. And you LA for Gen Chem, right? Too?
Yeah. I did like a big mistake.
What happened?
I told someone to like because they were waitlisted for Gen Chem, like Chem 2B, and they were number 3 on the waitlist. And they said like, "Oh, is it okay if I drop the course and register or like try to waitlist for one section that has 0 people on the waitlist, but it was full?" And I
Mm-hmm.
told them to do it, and they can't like waitlist again because it has an enrollment restriction, and I completely forgot. And yeah. So they
Were
basically
they
have
mad at
to
you? Were they
they're
mad
like
at
kind of
you?
sad, but
Oh.
that's the exact same thing I did for Chem 2B. Like I dropped the course and
Mm-hmm.
then I barely got in, so I'm not sure if they can get in again.
Oh my
So
God.
like I'm I didn't so they basically have to gamble. Like
Oh
someone
my
drops the
God.
course by
Yeah.
like week 3 and it's oh my God.
Do you know them in person, or was it through Discord?
No, no, no.
Oh my God.
No, they
You
asked me
you
because
trolled
yeah, I
them.
trolled them.
Oh my God.
I hope they actually get in. Like that's so bad.
Yeah,
One
yeah.
person has to drop.
Yeah, I know, I know. Like my sister right now, she is number one in the waitlist for 118B, so she doesn't know if she can get in
Oh,
this quarter or not yet.
I see, I see.
Uh-huh. Let's see.
Oops.
Mhm. Did you have any questions or topics you wanted to go over today?
Uh, is there any more to alcohols?
Alcohols, let's see. Grignard reagents, we went over that. Redox reactions, we went over that. Let me go check my 118A notes. Let's see.
Mm.
Just to make sure. Okay, okay. That's week. This one. Yeah. Four. Okay. Cause nomenclature. Redux. Camera 4. Jones. PCC. Reduction. LILH4. NABH4. Organic metallics. Yes. Yeah. Oh, um, so for another thing about green reagents is how to form them. So let me share my screen here. We could form green reagents but from halocane. Um, let's say we have this halocane right here.
Yeah.
We could convert that halocane into a green reagent by adding magnesium and ether. Like it could be like that ether right there as a solvent. And this magnesium here is just going to insert itself between that carbon and halogen to create this grignard reagent here, right? And notice how the polarity of this carbon here changes, right? Because that carbon right there was positively charged, partial positively charged, but now it is negatively charged, right?
Yeah.
So that's how we could change the polarity of that carbon atom. And then from there, we could react that grignard reagent with like the haloalkane, aldehyde, ketone, or any other electrophile, right? Carbon dioxide. Or it could do an acid-base reaction by adding alcohol or carboxylic acid. Okay. Synthesis of the alcohol. Oh yeah, so that was all of the alcohol reactions. That's all of the alcohol reactions. Yeah. And after that, we went over synthesis. Um, let's see here. We could go through the ATC alcohol practice problems and reinforce that before we move on to anything else. Yep.
Oh, sure, yeah.
Yep. Mm-hmm. Let's see.
Wait, is there a difference between the Grignard and organolithium for a reaction?
There is a slight difference in basicity, but that doesn't really matter when we solve like predicted product problems, synthesis problems. So there's no
Oh,
difference
okay.
in paper. But in reality, the lithium one is a little bit more basic, but
Okay.
they do the same thing. They do the same thing. One, two. Okay. Okay. So these reactions here are just gonna be talking about how we prepare alcohols, how we synthesize alcohols. Um,
Oh,
for each reaction, try guessing what reaction we're doing and explain to me the mechanism.
okay. I think this is a thing we learned in class from lecture.
Mm-hmm. Yeah.
Let me just pull it up.
Yep.
So, do I just tell you what will happen?
Yeah. Tell me what would happen
Okay.
in the
Uh,
mechanism. And I
for
think,
the oh wait.
oh yeah, yeah, yeah. Go on, go on.
Oh, we're trying to make it.
Mm-hmm. We have this haloalkane reacting with water. Um, I think you learned about this 128A. Did you? I think you learned about SN2, SN1, E1,
Yeah, we
E2.
learned all the
Yeah,
table
yeah.
of doom.
Uh-huh.
Yeah.
This is one of those reactions here.
Okay.
Uh-huh.
So let me pull the table out. Sorry, I don't have it memorized still. I need to
Mhm.
memorize it.
Yeah, it's okay, it's okay. So for this one here,
It's a poor nucleophile on a
yep.
tertiary. It should do SN1E1. We have a
Mm-hmm.
good leaving group.
Yep, yep. For nucleophile, tertiary, good leaving group, present, SN1, E1. That's correct. So now let's talk about the mechanism. Explain to me how you draw the step-by-step arrows for the mechanism.
Uh Wait, you just say like the leaving group, you, like draw
Mm-hmm.
an arrow from the bond between the carbon and the iodine
Yep, leaving group
off onto
leaves,
the, yeah. And that
right?
makes a tertiary carbocation.
Uh-huh. Tertiary carbocation.
And then the water adds, it comes
Mm-hmm.
into the, yeah. And that makes
right?
an oxonium.
Hmm.
And then you have, wait, would you say the I would come in to deprotonate it, make hydroiodic acid
Yeah, you could use I,
or
but it's gonna
H2O?
be more accurate if we use
Okay,
H2O because there's excess of H2O versus one equivalent of iodine. So the H2O
okay,
would overpower that I.
okay. So you
Right.
just, yeah, the lone pair on the oxygen takes the H and then the bond goes to the oxygen
Right, you got
to
it. And
make
that
a
forms,
tertiary alcohol.
yep, tertiary
Okay.
alcohol and hydronium ion as a side product when water grabs that hydrogen. Right. Nice. Um, let's talk about this one now.
Okay. This looks like a, this looks like a hindered primary, right? The substrate.
The substrate is a hindered primary. That's right. Uh-huh. Hindered.
Wait, so would the alpha carbon be the carbon attached to the bromine directly? The alpha one?
This would be the alpha
Or,
carbon. Yep, that would be the
okay.
alpha carbon.
I forgot when it was unhindered or hindered based on the alpha carbon. Um,
Yeah, so this is a primary substrate because it's only attached to one other
yeah.
carbon, but the carbon that it is attached to, well, well, I think of this as the substrate carbon instead because this is how like Levens taught it. But in most
Uh-huh.
OChem classes, that's the alpha carbon. But Levens calls it the
Uh-huh.
substrate carbon, and this is the alpha carbon, and this is the beta
Oh,
carbon,
okay.
right? Because the way that Levens taught it is that the alpha carbon is one carbon away from the substrate carbon,
Okay.
right? But other classes they will say that this first carbon directly attached to the leaving group is the alpha carbon. Mhm.
Okay, okay.
Yeah. Hmm.
Um,
And we see that the alpha carbon here in Levens terms has more than one
more than one.
branch attached to it,
Yeah.
making it a hindered primary substrate. Right.
Wait, if the substrate had like a lot of carbon branches, but they're all primary,
Mhm.
like there was just like a chain, would it still be unhindered?
A lot of branches like this.
No. Just
Uh-huh.
like a
Oh,
alkane,
like this, like
alkane.
okay, like
Yeah.
this.
Yeah. Would it still
Yes.
be unhindered?
Yeah, this would still be
Okay.
unhindered. Even
Okay.
though like this is longer than this right here, this is still unhindered.
Okay. It's
Hmm.
just that when there's two or more branches on the alpha carbon becomes
Yep.
hindered, right?
Hmm.
Okay.
If there's two or more branches on the alpha carbon, then it's considered hindered primary.
Okay. Um, this looks like a CH3CO2. Wait, what the? Wait, this is a two-step process?
Two-step process. Two-step process. Oh, yeah, I think
Oh,
Levens probably went over this too. It was
wait,
one of
what?
those 118C reactions that we don't need to know the mechanism for yet. But
Oh, I don't think I've learned this then.
oh, okay. So for this one here, how would you draw the bond line structure of this condensed formula here?
Uh,
CH3CO2Na.
just just draw CO2, but then on the carbon, you just draw a methyl branch. Like,
A CO2. So let's say this is the C right here. How would you draw the two oxygens attached
oh wait,
to the C?
hmm, try
Right.
drawing it
So
out.
if you see sodium here, what charge is that associated it
It's a
with?
plus.
Plus charge, making this
Oh
one of
wait,
the
so
oxygens.
one of the oxygens will have a double bond, the other one would have a single bond.
Yes. A single bond.
Yeah.
Right. But and a negative charge like that.
Yeah.
Right. And this is a carboxylate. Carboxylate.
Oh yeah, I didn't learn that.
Right.
Carbox.
Uh-huh. So when you see CH3CO2Na, it's going to look like this. And you can think of this as a deprotonated carboxylic acid. Right.
Okay.
The conjugate base of a carboxylic acid. This right here would be considered a weak base, strong nucleophile. Weak base, strong nucleophile on a primary hindered substrate with a good leaving group would give us what reaction would you say?
Strong. Weak base. Strong. Oh, weak base strong. Oh no, hindered. SN2.
SN2, yes, SN2 reaction. So, what would the mechanism look like here for SN2 reaction?
You would draw the carboxylate ion uh attacking the like carbon attached to the bromine, and the bromine would get
Mhm.
knocked off in this at the
Yep.
same time.
Yep. At the same time,
Yeah.
simultaneously, backside attack. In this case, there's no stereochemistry, so we don't have to worry about that. But it would substitute that bromine
What?
with this carboxylate here. Now, what
Okay.
functional group, no group, do you see present in this intermediate that we just formed?
Oh, wait. Is it anhydride?
Anhydride is
Oh,
close.
I don't remember that. They all look
Right.
similar.
Yeah,
Uh,
yeah. This right here is anhydride. It's
oh,
very
okay.
similar to ether, the name ether. It starts with the
Ester?
E. Ester.
Ester.
Yes,
Oh, okay.
ester,
Never mind.
ester. Uh-huh.
Ester.
When you see a carbonyl, well, if you see an ether like this ROR here and a carbonyl like adjacent
Yeah, that
to
was
it,
ether.
then it becomes an ester. Yes, yes.
Okay.
Now, once we have this ester here, when we put in the next step, NaOH and water, this is gonna do something called ester hydrolysis.
Oh,
This is a 118C reaction, and you'll learn about this at the end of 128B, 128B, right? The
mhm.
carboxylic acid derivative. Um, so we don't have to worry about the mechanism yet, but we do need to know that this ester here would be converted into an alcohol like that, right? Because what we just did here is that we cleaved that bond between the carbonyl carbon and
Mhm.
oxygen, and this part here is the alcohol product. This part here is going to be the carboxylic acid product.
Okay.
Yeah.
So SN2.
Mhm.
Um,
So the first step was SN2. Second step is ester hydrolysis. So two-step problem here.
ester hydrolysis.
Ester hydrolysis, right? Ester hydrolysis is when you have an ester reacting with NaOH, water, or acid water, and that would give you alcohol and carboxylic acid.
Okay, I see, I see.
Yeah. Mm.
Are the 118A kids are like expected to know ester hydrolysis? The
Yeah. Hello, hello. Can you hear me?
yeah.
Okay, okay. Yeah. So ester hydrolysis is going to be in the carboxylic acid and the derivatives section.
Okay.
Yeah. Did you learn about this in 128A from Leavens?
No,
No.
no, she
Okay.
didn't
Okay.
cover anything about esters.
Okay. Okay. Let's
It
get.
was all like simple SN1, SN2, E1, E2 mech, and then
Mm-hmm.
like reduce selectivity.
Readjust activity. Yeah. Let's see.
Yeah. Okay. Um, that seems like it will do SN1, E1.
Yep. SN1E1. And we went over this mechanism in the first part A. Leaving group
Yeah.
leaves, carbocation gets formed, water attacks, oxonium ion, and then another equivalent of water deprotonates and neutralizes to make alcohol. Like that. Right. Okay.
I'm still running it out.
Right, right.
Plus.
Let me go get water really quick. I'll be
Okay.
right back. Okay, I'm back.
Okay.
What if I changed this problem and I added methyl group here?
hmm. I would do a carbocation rearrangement, and it
Yes,
would make a tertiary alcohol.
right. Mm-hmm. If that was a methyl group there, we would do a hydride shift or carbocation rearrangement to form the tertiary carbocation and eventually form the tertiary alcohol, like you said. You got it. Nice, nice. And a second equivalent of water here is going to come in, deprotonate that oxonium ion,
Yeah,
and give us our neutral tertiary alcohol, like that.
cool.
Nice. Uh-huh. Hey, Elysia.
Hi, Bryant.
Oh.
Is this another ester hydro? Oh God.
Yeah, it is another SI hydrolysis, but there is something a little bit more complicated in this problem than the last problem.
Oh,
Um,
okay.
uh-huh. It's specifically about the first reaction.
Hmm. Oh, is it because of the
Yeah,
stereochemistry?
something about the stereochemistry.
Uh, so this is weak base nucleophile. Oh, so it would do backside attack and invert the stereochemistry.
Mm-hmm. Backside attack, invert stereochemistry. So that wedge will be inverted into a dash. And then from here, the second step would do ester hydrolysis, cleave that bond between the carbon, carbon, and oxygen to create the alcohol, which still maintains its dash bond because nothing touched that dash bond right there,
Yeah.
and give us this carboxylic acid right there. Right.
Oh, yeah.
Yeah, but the important thing that they wanted here for this section specifically is this alcohol. But when you learn about carboxylic acids, this is also going to be important, that carboxylic acid that gets formed.
Okay. Two. What the E? Like 3. It will do SN1. Wait. SN tertiary. Is it SN1E1, right?
Yep, you got it. Tertiary, weak base, weak nucleophile, or poor nucleophile, good leaving group present, SN1E1. Nice. Right. Now, how would the mechanism look like here?
The BR would leave, and
Mm-hmm.
you would lose the dash stereochemistry. You just draw like a line for the
Mm-hmm.
methyl.
Yep.
Carbocation, yeah.
Yeah.
And then water comes in, and then it gets deprotonated by another water.
Yep, you got it. Just like that. Okay. Okay. This last one for this one here. This one, after you do this one, I want to give you a different one that's similar to this, but it would change the answer like by a lot.
Oh, okay.
Yeah.
This is strong nuke unhindered. SN2.
Uh-huh. Right, because this is a strong
Strong
base,
base unhindered.
strong nucleophile, unhindered. Yeah.
It would
Um,
just make the
primary
BR and OH, I think. Yeah.
unhindered. Yep. The OH minus here will attack that carbon, kick out the bromine, and just
Yeah.
substitute
OH. Yeah.
like that. Right. What if our molecule was this instead, and we
This is
reacted with,
secondary.
yeah, secondary substrate.
It's a new E2
Uh-huh.
Zaitsev.
E2 Zaitsev. Right.
Okay, well, there's
So
like no particular way of it because it's Oh wait, adding that. Oh, never mind.
Right.
Oh, looking for the anti-periplanar hydrogen.
Anti-periplanar. Oh, okay, okay. You want to add the anti-periplanar thing there too? Let's do this then. Let me make it a little bit difficult.
Well, you can draw the imaginary. Yeah.
Yeah, this is gonna be a little bit difficult.
Wait, let me screenshot and try to edit.
Okay, okay.
So it'd be I want this to be dashed H. Wait, what the heck? Oh, I see, I see. AOH. Besides that, this one leave. And then the OH would grab that hydrogen, pushes the bond to, okay. One, two. mm, Hmm. I think I got it.
Okay.
So what
Um,
I did is I just rotated the
uh-huh.
sigma bond in my
Yeah,
head.
this one right
Or like
here.
I drew it out, yeah.
Yep. Right. Yeah, yeah. That was the tricky part that I wanted you to test you on this problem here. You got it. Right. And that
Yeah.
would make that methyl group go like that. Wait, hold on.
Yeah, I
Boom.
drew a meth. Yeah,
Like this. Uh-huh. And that would make this hydrogen here
dash, yeah.
dash, which is anti to the leaving group,
Uh-huh.
fulfilling the anti-periplanar transition state. And when we go
Yeah.
for the
The
Zeit
three
cell,
arrows.
yep,
Yeah.
3 arrows. Creates this.
I believe it wouldn't be, yeah, it would lose the stereo chem because SP2, yeah.
And would this be have you learned about
Oh,
E or Z alkenes? Yeah, like E or
yeah,
Z.
yeah, yeah.
Uh-huh.
Yeah.
What would this one be?
Uh, wait, this would be one, two, two. Z.
Yep, Z
All right.
alkene. And just for extra practice, or actually no, that's more for Elysia. Elysia, um, can you name this alkene right here? Because I think you did the nomenclature of alkenes 128A, right, Riley? Like last quarter.
Yeah, yeah, yeah.
Yeah, yeah. So Elysia,
It's not too bad.
yeah, this one. Let's try the nomenclature for this one. Oh, are you talking, Elysia? Hello, hello. Are you going over ethers after alcohol, Riley? Like after that?
Sorry, I just used the restroom. What?
Oh yeah, yeah. Are you
Uh,
going over ethers after alcohols?
like on the schedule or like whatever.
Yeah, yeah. Like on
Oh,
the
I
schedule.
have no idea. Let me
Oh, okay,
check.
okay. It's okay,
Let
it's
me
okay.
check
We'll
really
just
quick.
focus on alcohols for now.
Oh, lecture notes. Oh yeah, ethers, I think.
Ethers. Okay,
Yeah.
okay.
Yeah.
I'm trying to pull up the first image. Um, Okay, so let's continue with the alcohols.
Oh gosh. condensed formula.
Condensed formula. I hate it. I hate it so much.
Levens did like she always did bond line, so like
I
when
know.
BL does like all this condensed formula, I'm like a little bit lost, but
I know.
it
And then
takes a
like
little bit of time to like visualize
visualizing it, right? And sometimes they do it like this: CH3, CH2, CH2, CO, CH,
Yeah.
uh, something like that.
Yeah.
Yeah, yeah.
Oh,
CH3, 2. Yeah, yeah. Oh my gosh.
yeah,
That
it's
takes a while. Mhm.
yeah.
Okay.
Uh,
So, oh yeah. Elysia, were you able to figure out this nomenclature?
Yeah,
Uh-huh.
is it, we're counting it by the longest chain?
Yes, that's the first step, the longest chain.
So is it butane? But
Mm-hmm.
but we have to change the ending to suffix ending to "ine," but we have to, um, I know we have to do, is it, uh,
are you
Uh-huh.
sure it's a butene? I thought it was a
Oh,
pen. That's
right, right,
five
right,
oh,
right, right.
carbons
yeah,
for the
Yeah,
longest
yeah,
chain.
yeah,
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 that,
yeah,
that probe.
Yeah.
Oh,
yeah.
yeah,
The longest
pent.
chain
Should
is
be
the
the
smallest.
longest one. Yeah.
Right, right, right. And how would we number it, left to right, or like should we go this way or should we go this way?
The left to right, I think, because we want it, the the alkene to be on the shortest number,
Mm-hmm. The lowest number. That's right.
the lowest number. And
And
then,
uh-huh.
is that considered a, oh, so then if that's part of our main chain, then we would have like a methyl attached, so we would indicate on 3-methyl.
Uh-huh. A substitute on carbon 3, which is the methyl. So the first thing would be 3-methyl.
And
And
then
from here, yeah, go on, go
is
on.
it propene?
Propene. So propene would be 3
Oh,
carbon
but we
long,
have to do the, oh yeah, 2- propene, I think.
2 dash
Or probe 2-ene.
wait. Oh, pentene.
Oh yeah, pentene, yeah.
Pentene. Right. It could be 2 like -2 pentene, or it could be
Yeah,
pent-2-ene, like you said.
right.
Right. Yeah, like that. 2-ene. And for stereochemistry, because this is a Z alkene, we could put like Z right here in the
Okay.
beginning of the name and a dash to show that we have a Z configuration. Nice. What carbonyl compound and hydride reagent could you use to make the following alcohols? Oh, okay. So they're saying that these are the products here, these alcohols.
Oh, they work backwards. Oh
Yeah,
man.
go work
Okay.
backwards.
Okay, so it's like the acid-base reactions you did yesterday, right?
Redox reactions.
Redox?
Redox, right. Uh-huh.
Wait, what? Redox. Oh, I see.
Right, because they're asking for a carbonyl compound and a hydride reagent. A hydride reagent, think of that as a
Or
reducing
the H4 stuff. The
agent. Uh, NaBH4
yeah,
or
yeah, H4,
NaBH4.
yeah.
Right.
Those
Right, H4.
secondary. Wait, which carbon? No, right. Wait, this is
Let me convert it to bond line form so it's easier to read.
no, I'm just thinking
This is
like how do
pretty
we work
real.
backwards?
Uh-huh. Yeah.
Secondary. Oh, I think first one, yeah, it's supposed to be OH, not a double bond O.
Oh, right. Yeah. That's OH right there. Okay. So these are the the products.
Oh man, okay. Secondary. For the first one, would you just replace the like for the substrate, you would just make the alcohol into a ketone, right?
Yeah.
And then you could use either NaBH4 or LaH4,
Yeah, doesn't matter.
and then acid workup.
Yeah.
Okay.
Yeah, yeah. Nice, nice. You got that.
Wait, for B, could you assume that there's just like one alcohol that's going to get reacted and just leave the other one there, or is it
Oh
both
yeah,
going to
you could
react?
assume that. Yeah, yeah, yeah. You can do that.
Oh,
They
okay,
didn't
okay.
specify.
Wait, then
Uh,
can I just say the same thing except at the end it's just alcohol for
yeah,
the
you could do
reactant?
that.
Okay.
That works too. Yeah. Uh-huh.
What the heck is this one?
So for this one would actually
Is
matter
it?
which one you use, like which reducing agent you use.
No, I'm thinking about the reactant. I
Oh, the reactant? What the
yeah,
reactant would look like?
because I'm thinking about using a ketone again, but like in the
Uh-huh.
original it has a ketone.
Yeah, yeah, yeah. That's
Or
right.
not ketone, it has a
It- it-
ester.
yeah, the ester
Oh,
would
oh yeah,
be
okay.
there, and the ketone would be there. That would make the alcohol. This is the reactant we want.
Oh, okay, all right.
But what reagent would you use to convert this to this specifically? And think about the strength of the reducing agent.
Would I want to use the stronger one? So I would use the Li.
The stronger one, well, this is
Oh wait.
going to also reduce ester. So any carboxylic acid derivative, like ester, carboxylic acid, think of this as a carboxylic acid. The strong one would also reduce the ester into an alcohol. Right. So if we
Wait.
used LiAlH4, second step H3O plus, we're going to reduce the ketone and the ester.
Oh, okay.
Right. But
Hmm.
we don't want to reduce the ester down. We want to selectively reduce the ketone only. So that means that we have to use sodium borohydride, the weak reducing agent, which would only selectively oxidize the ketone into the alcohol. And the weak reducing
Oh, I
agent
see.
cannot reduce the ester. So that's why the ester stays unchanged.
Wait, esters?
Yeah. Ester, so carboxylic acids, esters, they cannot be reduced by
Okay.
amides as well, amides and nitriles. You'll learn this at the end of the
Yeah.
quarter. The derivatives cannot
Oh, they're all derivatives. Oh, that's why.
be reduced by NaBH4. There are two derivatives of the carboxylic acid that can be reduced by NaBH4. And those are the most reactive derivatives, the two most reactive derivatives. You mentioned one of them earlier, which is anhydride,
Oh,
and the other one is acyl halide,
oh,
where
yeah.
X can be chlorine or bromine. These two can be reduced
Uh-huh.
by NaBH4,
Okay, okay.
those two derivatives. So NaBH4, they can only reduce like, well, in this case, either acyl halide, anhydride, ketone, aldehydes. And when you learn about imines and amines, they could also reduce imines as well.
Okay. Yeah.
Imines.
I didn't know there's like selectivity for
Mhm. For redox, yeah, there's some
Yeah.
sensitivity. Right. Uh-huh. Okay. Let's see. Elysia, what did you go over today in Helix's 118B lecture? Or did you guys had lecture today, right? Tuesdays and Thursdays?
Yeah. We went over like E2 reaction stereoselectivity, regio selectivity.
Uh-huh.
I think alcohol dehydration,
Uh-huh.
and I think that's about it.
Okay. I see. I have one of his midterm questions put up here. Let me give you one problem, and then we'll work through that. Unless you have any questions or problems you wanted to go over specifically.
I don't have any specific right now.
Uh-huh. Okay. Let me give you this here, and let's work through them.
Okay.
So this question here is asking for, say, we have that halocane, and we reacted with a strong base.
But Helix just writes strong base.
Yeah, he just writes strong base.
Yeah.
Yeah, I know.
Wow.
Strong base. And here are the option choices.
Bro, is it like MCQ?
Yeah,
Oh
multiple
wow.
choice.
I'm so jelly.
Yeah. This is Helix has multiple choice questions, explanation questions, vocab.
Wait, so you can
Oh, no,
like
not vocab, not vocab.
yes. Oh, no vocab.
No vocab. Yeah, no vocab, not like Layton's.
Oh,
Predictive product, mechanism, synthesis, spectroscopy. For
I
spectroscopy.
see.
Yeah. So this is A, B, C, D. And the question is, which one would give the Zaitsev product?
Wow.
Would it be? I think B.
B. So how many R groups are attached to this alkene right here? If I were, let's say, circle this one, and this whole thing right here.
So 3.
3, right. This one is 2, so 3 is bigger than 2. This one right here,
4.
4. Yeah, so this one is tetra substituted, the most substituted one, making C the answer. Right. I think B looked like the right
Okay.
answer because it had this bulky R group, right? Like the isopropyl
Yeah.
group right there. Yeah. C.
Okay.
See. Have you learned about probably oxymercuration, demercuration?
I don't think so.
Okay.
I don't think they learned the max yet. Like it's still week 1.
Still weak one, yeah.
Yeah.
Let's do this nomenclature problem here. Like that. Includes stereochemistry as well.
Okay. I say the longest chain is octane.
Octene.
Octene. Yeah.
Octene. And we want to go what direction for the numbering?
From right to left.
Yep. Okay.
And then we have 2 methyls attached to that long branch. So it will be on the 3 dash, that one, and 3 and 5. And then
3,5.
that'd be dimethyl.
Dimethyl.
And then we said octene, and we say it's on the 3 alkene. Yeah.
Yep.
So it would be 3 dash octene.
Yep. Or
or oct3ene.
yeah, that's right. And now the only missing thing here would be
The E or Z.
yeah.
So it would be Z.
Yeah, you got it. Z. Yes. Yes. And I don't know if you heard about this yet, but the way that you can think about it is that if the bulky groups are on the same side, it's Z, the same side.
Same side.
The
Yeah.
same side. Yeah. Did Helix say that too?
Yeah, he said it, but I think I heard it first from you.
Oh,
Oh,
Levin said it
Yeah.
too.
yeah. Levin said this. Yeah.
Yeah.
Like I've been always using it. It's so funny. It's the same side.
I think the ones that trip me up is like if one alkene carbon is part of the main chain, so then it would be like methylidine, like that, those
Oh,
ones,
those
or
ones.
like, yeah, or I think there was another one, another situation. I think it's
This is one of it. Yeah,
or
there is.
like the ethanol, like where there's
Oh,
like a
ethylene.
vinyl, like
Ethylene.
yeah, like
Yeah.
ethanol, or like a enol.
Uh-huh. Yeah.
Yeah, those ones.
Right. Oh, that's N118B.
Like where, yeah, when they're attached to like a cyclohexane, but
Mhm.
like they're not part of like the inside of the cyclohexane. It's like kind of branched off.
Oh, like this.
Yeah.
Yeah. Ethylene. I think. I have to brush up on nomenclature. Yeah, it's rusty right now. Um, but this one here, like it has one of those things that you just mentioned.
Yeah.
Yeah.
Um. Yeah, and then so then that one's an ethanol,
Uh-huh.
and then
Ethan.
the other one is um. That one's an alcohol, but then don't we give priority to the alcohol?
Uh-huh. We do. And this one here, we don't say ethanol because ethanol says that we have an alcohol as the base functional group. There's no alcohol here, so we would call this something else. And because alcohol takes the priority group, this would be our number one carbon right here, right? And it doesn't matter where we number it because it's gonna end up the same way, clockwise or
Right.
counterclockwise. This group right here is gonna land on carbon 4 either way. So that since the alkene is like it's part of the backbone, like the main chain, this is gonna be for ethylidine, right? Because it's 2 carbons long out of the main chain. It's a substituent 1, 2. But because it's like part of that main chain, but it's not like the main chain,
Yeah.
you put ilidine. And there's something with like just ylene as well, I think. But I have to review my nomenclature rules.
Mm-hmm.
On alkenes, I don't know what this one is here. So this one would be for ethylidine. The main chain is cyclohexane. No, cyclohexane. No, and the one here for all is optional because if it's a cyclohexane, then you could put one on as assumed. Like you could assume the alcohol is on carbon 1 for the cyclohexane.
Oh, okay, okay.
But keep this in mind, if it is not a ring, right? Like if it was a linear chain like this, 2, 3,
Mm-hmm.
4, 5, 6, and then alcohol is on carbon 1, you cannot assume that the alcohol is on carbon 1. You have to say 1 hexanol or hexane 1-ol.
Mm-hmm.
Because the alcohol could be on any carbon 1, 2, 3, 4, 5, or 6. Wait, no, like 1, 2, or 3. You could say because we can't go 4, 5, or 6. If this is the main chain, because if we say 4 hexanol, that's not the complete name. And can you explain like why? Can you think of a reason why that's not the correct IUPAC name?
Um,
And this is a Pascal type question. Pascal.
I feel like we uh, Well, cause
Uh-huh.
it's to like kind of you use that to designate or like assign like other things that are there, right?
Mhm.
Like so like to specify, like let's say there was an alkene somewhere there,
Mhm.
then you would kind of use that to indicate
Mhm.
the
Oh, like
the other,
the numbering thing?
yeah,
Yeah, the numbering thing would indicate other things there, and it would also indicate where the base name is too, like how we did in alkenes. Like we in these examples here, we indicated where the alkene was from the 3-octene or three
right.
like octene. So we could still indicate where the alcohol is, but when we indicate where something is, do we want to number it like the lowest number possible or the highest number possible?
The lowest.
Yep. And in 4-hexanol, do you see a problem here? Like, is this numbered the lowest possible?
No, it should have
Mm-hmm.
been like two dash hexanol.
Yes. Uh-huh. Should have been uh 2-hexanol. That's right. That's right. So that was a tricky that was like a tricky question from Pascal's quarter for 118B.
Yeah, Helix was saying that for like alkenes, it doesn't like I think he was saying something along the lines where it doesn't have to have the alkene in the chain, or you shouldn't like rearrange the order of like that if you that you number it,
Mhm.
even if like um I think he's saying that not in it's not always the case that you include alkene in your numbering the 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 long chain, that we mostly prioritize like the alcohol.
Yeah, we mostly
He was saying
prioritize
something like that.
the alcohol. And this is another exam that he had where it had an alcohol and alkene. Let's do 2 more nomenclature questions, and
Okay.
let's go for from there. Right, this one you have to name it, and the second one you have to draw it.
Okay.
Yeah. Wait, Wiley, Leavis also said the same side for Z alkenes when she went over the
Yeah.
stereochemistry. Oh my gosh. Let me see something. Okay. Wiley, I want you to try A and B right here for the organometallic.
All right. What does it mean when there's two reactants in?
Oh, if there's two reactants, then they are going to react with each other if they can, but if they can't, then they won't do anything to each other. So if there's two reactants, look at the reagents here and see what this first reagent will do to like either this
Okay.
reactant or this reactant. And after you do that, see if they can react with each other after that transformation.
Um,
Right. Because right now, the way that the reactants are shown, that haloalkane and that aldehyde will not react with each other. Like they don't
Yeah.
react with each other at all because they're both electrophiles right now.
I think I got it.
Mm-hmm. Let's see it. Let's see it.
So for the first one, I numbered it like alcohol, like the alcohol side, so right to left.
Mm-hmm. Yep. Yep.
Um, wait. And then after that, so it was I think heptane. So I said hept
Mm-hmm.
dash 5 dash ane
Mm-hmm.
dash 1 dash o. I'm not sure if that's correct though.
Yeah, that is like almost correct. Like the dash, but then the numbering on the alcohol. Be careful. Is it on carbon 1 or is it on carbon 2?
Oh, 2, sorry.
2.
I made that
2.
mistake right there.
Uh,
Yeah.
yeah. 2. Oh, yep. Mm-hmm. That's gonna be the base name.
Yay.
Uh-huh. And
Okay.
there's something missing. There's some two things missing here.
Is it the uh it's trans?
That's one of it. And there's one substituent here. There's one
Oh,
substituent.
the methyl.
Yeah.
So be 2 methyl
Mm-hmm. At the beginning of the name.
and then E.
Yep. And an E. That's the full name.
Oh,
Right. Uh-huh.
okay.
Yep. Nice. Nice.
Yay.
Mm-hmm. And for this problem here, I want you to
Yeah,
draw out the structure.
I think I did.
Uh-huh.
So I just drew out my long chain.
Uh-huh.
So it's 8 because it's octene.
Mm-hmm.
And then I gave 7 2 chlorines.
Uh-huh.
And then on 3, carbon 3, I drew in, I guess it's called an ethylene.
Mm-hmm. Yep. Yep.
So then there would be like the double bonds on the 3
Mm-hmm.
ene.
Yep. Yeah, that's it. You got it. 100%.
Yay.
That's it. Okay. Wiley, were you able
Yeah, I
to
did it, I
do
think.
these two? Okay, okay, let's see it. Let's see what you did.
Uh, I drew the 5 carbon from the reactant, 5 carbon
Yep.
chain.
Yep.
On the 3rd carbon, I drew an OH
Mm-hmm.
on the top.
Yep.
Yeah. And then I drew, see an isopropyl.
Yeah, you got it.
Yeah.
That's good.
Okay.
You got it. Uh-huh. Nice.
And then, okay, for this one, I just drew after everything,
Mhm.
for the cyclohexane ring.
Mm-hmm.
And then on one of the carbons, I just drew an ethyl. And then
Ethyl.
on the first carbon of the ethyl. I just wrote OH.
Yeah, that's it. You got it.
Okay,
That's it.
cool.
Yes. Okay. Nice, nice. Alright. Like, I'm surprised you guys are showing up to first week office hours. Like I thought no one was gonna show up this first week office hours. I thought people were gonna show up like but when it gets closer to like the exam season. But you guys are
It
like
probably will,
on
yeah,
top of it.
full.
Yeah.
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 Yeah. See. Well, thanks for coming, guys, and good luck. Good luck.
Yeah.
Good
Thank
night.
you.
Thank you.
Yeah, no problem. Bye.
Bye, guys.
Bye. Good night.
Bye.